So we're talking about significant figures and measurement, and what does it all mean? Why does it matter? Why do we need to know significant figures? What does it mean in the real world? Well, keep in mind, you always have to remember that most of the numbers that we're talking about in chemistry and science are measured, right? We measured something, we did an experiment, we took some data, we measured. So when we measure, the measurements that we make depend on the tools that we use. So I just wanted to show you really quickly and pretty straightforward what's the difference between the instruments we use and how does that affect the significant figures that we have. So, for example, these big beakers, this one, as you can see, right, it has a mark at 200. It doesn't say it, but that's 300, 400, and so on, right? So its markings are every 100. The unit here is milliliters. So that means that when I'm measuring, if I'm using this beaker to measure, I can only say for sure, and I'm going to put a picture up here a little bit closer up, I can say for sure that the liquid in here is above the 200 milliliters and below the 300 milliliters. I can estimate, so that's the hundreds, I can estimate that maybe it's 210 milliliters. Maybe it's 220, maybe it's closer to 200 even, but I can only estimate one place past the markings on my container. So since this container is only marked every 100, I can only estimate to every 10. I can't estimate to 1 because there's no marking to even estimate 10. So you can only go one digit or one place past your the markings on your container. So, depending on what you're doing, this may be fine. Beakers in general aren't made for measuring very precisely, as you can see, right? Because if I only know it's between 200 and 300, that doesn't give me very much precision. Okay, so if I use a different tool, okay, still a beaker, still not the greatest measuring tool, but this one, it's a little smaller, and now I have markings at 20, and there's a mark in between that would be 30, 40, 50, 60, up to 80. Okay, and again, the unit is milliliters. Units are important. So now I have the markings at the tens, which means, and here's the close-up, if I have markings every 10, I know that the water level in here is between 30 and 40. Before I could only say it was between, say, 200 and 300. Now I can say it's between 30 and 40, and I can estimate that, maybe it's 34. Okay? You could argue, and I couldn't really argue about it too much, you could argue maybe it's 33, maybe it's 35. That's fine, because it's an estimate. But we can all agree that it's between 30 and 40 because the markings on the container tell us that. So we're going to estimate the ones because the markings are at the tens. Okay? All right, so now we take a graduated cylinder. Now these are a little bit more designed for measuring amounts of liquid. That's what they're for. This one has markings. So here's 20, here's 30. There's markings in between at the ones. Okay, so now I'm marked down to the ones, which means I can estimate to the tenths. Okay, you always go one decimal place or one place past the markings. So looking at the close-up, I might say that this is 27.8. Okay, because I can estimate the 0.8. I know it's between 27 and 28. No, I don't. I know it's between 26 and 27 because the markings are at 26 and 27 and the water's in between somewhere. So I could say it's 26.8. You might look at it and say it's 26.7 or 26.9, but we all would agree, or should be able to agree because the markings are there, that it's between 26 and 27. So always use the markings that you have and then estimate one place beyond that, or one place below that. So we're at the ones, we can estimate to the tenths. When we're at the tens, we can estimate to the ones. When we're at the hundreds, we can estimate to the tens. And then if you wanted to get even a little bit more precise, we can use a smaller graduated cylinder. Okay, now this one, you can see it's got a big mark at the 6, a big mark at the 7, and little markings in between. That's the tenths. So this is 6.1, 6.2, and so on. Because I have markings at the tenths, I can estimate to the hundredths. Okay, so looking at this one, and this one especially, as the tubes get narrower and narrower, more and more narrow, you get this thing called the meniscus, which is where the water sort of dips, almost looks like a bubble. So you always want to look at the bottom of the bubble. This one is pretty close to 6.6. It's between 6.6 and 6.7. So I might estimate that as 6.71 or 6.72. Again, that last digit is an estimate. The last digit might vary from person to person slightly, but we should all agree it's between 6.7 and 6.8. Now you might even say, wow, I think that's right on 6.7. If you think it's exactly on 6.7 and the marking is at 6.7, you would still estimate the hundredths place, one place past it. So you would say 6.70 is your measurement. You have to include that zero. Zeros are important. Sometimes they're considered significant, sometimes they're not, and I'll talk about the rules for how you know the difference. So again, looking at the different markings, we're restricted in our measurements by the tools that we use, and that's true whether it's graduated cylinders or meter sticks or balances, scales, or pressure barometers and things like that. We'll talk about those a lot later on. But we're always restricted in how precise and how accurate we can become. There's a difference between those two things by the tools that we use. So always figure out, before you start looking at your measurements, where do the measurements, or where do the increments, the markings on my device go? How far do they go? Because I can only go one place past that in my recording when I write down the measurement. You can't go past that because then you're just completely making up numbers, and for someone reading it, it can be misleading. If I said this, for example, right, if it's 200, let's say it's 220 that we estimate, but I wrote 225, the fact that I included that 5 indicates to the person reading it that I actually had a more precise instrument, that I was estimating to the ones because my markings were at the tens. And that's not the case with this big beaker. This big beaker only goes to 100, so I can only estimate to the tens, and then I have to put zeros after that to hold the place of the ones, because I can't estimate in the ones. So that's where this concept of significant figures comes from. It's because we have different tools and different levels of precision, so we have to report our numbers based on that.